the amount in billions of dollars. So this was the last application. I'm actually going to start with part C, and I'll get to why. All right, so first the problem. The amount, and I got to keep in mind everything's in billions of dollars spent by the top 15 U.S. financial covers on IT, so that would be information technology, outsourced, is approximated by that function from 0 to 4. So times 0 corresponds to 2014. And so this goes from 2014, which would be times 0, to 2018, which would be 4 years later. All right. Is AFC increasing or decreasing over the 4 years that they were given in the domain? So basically, when they did the study, it was over those 4 years. Interpret your results. Is it concave up, concave down over those 4 years? Interpret your result. Graph. I'm actually going to start with the graph. I'm going to do this entire function graphically. I'm not going to find any derivatives because based on the graph, I'll know information about the derivative. All right, so I'm going to go to and so carefully graph this. And again, we're only interested in over the domain. So I'm going to pop up my graphing calculator. And so I've actually got the graph up here. All right, so first thing is carefully type it in. So remember 0.92 parentheses. You got to change t to x. So x plus 1 raised to, so that whole parentheses raised to the 0.61. And then I'm going to change my window. All right. I know that my domain is 0 to 4. So my x values, I only am interested in from 0 to 4. Now, I usually go a little bit beyond so I can see the picture so it's not on the edge of my graph. But you could technically go 0 to 4. Not a big deal. But I am going to go from -1 to 5 so I can see everything. So I can see my axes. And I'm going to do it in both directions because I know my value should be fairly small based on the fact that it's raised to a 0.61. That means my exponential growth is very slow. Right? And so I did the same thing in both directions. I did -1 to 5 in my x direction. So my x max -1, my x min 5, scaled by 1, y min -1, y max +5, scaled by 1. And then hit graph, and there's my picture. Right? So again, I've got a little more than I need. I only need to go from 0 to 4. And so I'm going to find those points. So when I go to graph it, so I know where I start, where I stop. So I'm going to hit second trace, 0. And so my graph starts at the point 0.92, and that should make sense because if you plug in 0, you get 0.92 out. Second trace value, my function stops at 4, so I want to know where that 4 point is. So enter, and so it's going to stop it, and I'm just going to round it a few decimal places. So the graph stops at the point 4, 2.456, if I round a few decimal places. All right, so I'm going to go back to my notes, maybe if it'll let me. There we go. All right, so the graph over the domain. So again, I'm starting in part C. So this would be my years after 2014, starts at 0, stops at 4, right? My domain's just 0 to 4. And actually, since it's, so again, I'm looking here at my domain. So 0, if you remember, 0 was just at, I'm just going to mark it off, that was at 0.92, and then 4 was up here at 4, 2.456, if I round 3 decimal places. And then it has a slight curve to it, right? And it's important that I include that, right? If I go back and look at my graph, there is a slight curve. That's why it's helpful to see a little bit more of the picture so you can kind of see. What's important to recognize there is it's the concave down shape. Right? So you can answer the concave down question. Go back to my notes. Alright, so there's the graph of A of T. This is in billions of dollars spent on outsourcing IT. Make sure, again, biggest thing is in billions of dollars. Alright, so the first question is A. Is A and T increasing or decreasing? Well, it's increasing. A of T is increasing from 0 to 4. That means the from 0 would be 2014 to 2018. The amount spent, the companies, I'm just going to say the amount spent on outsourcing IT was increasing. Right, it was moving up, meaning the derivative, if you found the derivative, would be positive over the interval 0 to 4. All my slopes are positive. All right, if you look at the graph, that is the case. They're all positive. It's moving up. Rate of change is positive. All right, then again, that's why it was sort of important to see a little bit more of the graph, because here it might be hard to tell, because it's very, very subtle, that it's concave down. But if I looked at more of the graph, it was a little easier to tell, especially that beginning piece where that it showed that it was concave out. So part B is ask you if it's concave up, concave down. Well, it's concave down, and it never switched directions, so it's concave down of the entire piece. All right, so from 2014 to 2018, it was concave down. So remember what concave down means. It's how fast the slopes are changing, the rate of change is changing. So since it's concave down, my rates of change are getting smaller. My slopes are getting smaller. So even though they're outsourcing at smaller and smaller rates. So the rate is getting smaller. And so the financial institute, the rate, again, the speed that they are outsourcing, IT, is decreasing. Right? They're spending less and less, or slower and slower rates. Right? It's slowing down. Still increasing, but at smaller and smaller rates. Right? They're spending less on outsourcing. Right? So it's concave down, which means if you found the second derivative, it would be negative. Yeah, negative over that interval. It would come out negative everywhere between 0 and 4. Which again, you can do that graphically. So again, I sort of started with part C. Alright, that finishes up 3.2. Alright, the last, we skipped 3.3, so just make a note, we do skip 3.3. It's not there because we don't do it. And we go to 3.4, 3.5, and 3.6, which are all special types of applications. So we're sort of done with the rules. Now we're going to use this and look at applications. So we're going to apply finding max and mins in applications and finding absolutes in applications. So we're going to do more. Basically, from here on out, it's just applying what we know. Applications of what we know. Now we will get a couple more rules where we'll find, instead of relative max and mins, absolute, but really it's the same process. Right? The same process, we're just going to apply it.